Hello, everyone. Thanks for joining my third session of this Pakistan Dreaming 2021. My name is Abrar, and today I'm here to talk about microservices in Salesforce. Before we embark, I would like to say a big thank you to the organizers, volunteers, speakers, and our special guest speaker, Peter Chitham, for supporting this event by putting their time and effort. So, really appreciate it. Let me quickly introduce myself. My name is Muhammad Abrar Haq, but I can just go by Abrar. I have been working on Salesforce for almost over a decade, um, and I'm a certified application system architect. I'm also a public speaker, and I work for startups and global leading professional services firms. And currently, I'm working for PwC as a senior manager and Salesforce technical architect. So when I thought to submit this session, I thought that microservices is a term that these days is a buzzword actually, and people are using it in every integration when they are doing that, and also new applications are coming in and they also use the word microservices. So I thought is a good topic. It would be a good topic to actually present and share knowledge. And here I am considering myself as a student of this particular topic. So, so basically, I'm sharing the knowledge and sharing knowledge as people say that idea is a message. So before we begin, just a quick note. Although we are not going to discuss any features of Salesforce specifically, but just be always make sure that you purchase products and services that are currently available and not what you see here today. So this is the agenda for this session. First, we will briefly go into the background of microservices. We go into the history, how the software development started, and then we do the fast forward. We come to normal software development, application development, web development, and then we'll discuss what is microservice actually, and and are there microservices in Salesforce platform, and what are those, and how could we actually build one microservice for us for our integration platform. And then, of course, we go into the learning resources and we can take question and answers. So let's go back in time. So, you know, in back in time, we had computers similar to this here you see, where you need to provide an instruction, a particular instruction, and you need to perform few actions to actually execute that particular instruction. And that's what it is basically. And there were big size computers, and everybody takes time to actually read the instruction and execute the instruction, and so that was that time. Now, this is the kind of era of evolving of software development. And then let's do a fast forward. Um, let's talk about the normal actual application development. Now, what do? We basically, develop a code. We deploy that code into a particular merge file, and then we basically use to install that file into the user machine, actually. So what we are saying is that if you have multiple users, we need to go and install that particular software individually into those users' machine. But then what are we talking about later? Then there's another development that we're saying that, you know what, let's develop in a way that that's a modularized development. So we created our code in a modularized way. So if you have, let's say, product features, if you have catalog, then you actually create that different modules. It improves the code. It maybe slightly improves the deployment, as well, because there's now you are creating two applications, but actually you are merging it together. You are just, everything is just smushed, and then that smushed thing is going to deploy into the user machine. Now, from a modularized way, great, nice, nice pattern. But then we are talking about that later. Then we introduced web development. Now, earlier we were basically, everything was smushed after development of the code, and we install that into the user machine. If you have 100 users, 100 times you need to install that. Now we said, okay, well, let's talk about a web development. Now, in the web development, we have, of course, we're accessing a particular page in the browser. So HTTPS calls happening. Same model, modularized model, good. We create modularized code there. We everything was smushed, but this time now we are not deploying installing into the user machine. We are actually deploying that whole smushed code into the web server. And on that web server, we now users will be accessing from that web server using HTTP calls happening there. And then HTTP call comes back, and that page is loaded, and then user is able to see. Now that's the improvement. Now, you know, web application have been growing in complexity for a long time, because you know it's good that is to solve the problem of normal software development, where you don't need to now install the application on individual machines, user machines. Is better, good. But actually, the web application have been now growing fast, and then is growing bigger and bigger. Is From web application point of view, yes, you are able to access a particular functionality quicker, great. But actually, the scale of that particular demand is bigger as well. So bigger user base, bigger scalability, more complications there, and basically overall application is bigger, everything, right? So complexity is definitely you know increased, not just at how we handle or how we install, but actually complexity is going to be it has increased at the code level as well. So now you have more code, now you have more, which means that you have more servers. We're talking about runtime more, we're talking about execution of that processing at the CPU level. So it's not ideal. So, for example, why we are saying not, why we talk about that, because now here you see a word called monolithic architecture. Why we are saying that? Because you are creating a modularized code, which is good. You are producing a one smashed file, great. You are deploying into the server, that's also great. You are then and user are basically accessing that particular application by having a connection between their user machine, browser, and as well as web server. So all the HTTP, HTML files are actually loading and rendering on the page on user browser. But let's give an example where in the same pattern you need to add or advance a new feature. Now, how do we do that? Well, maybe in module B we need to add a new feature. We added that, which you can see highlighted here. But what does it mean? How do it requires it has consequences, right? You need to add a new feature. What does it mean? It means that it will be difficult to deploy again, because you need to have a proper regression testing. And if you don't do that, you will be in a risk to actually have more problems on your production level, right? Scalability is also a problem, because what are we talking about here is that when, let's say, at a particular time frame, let's say Black Friday comes in, and at the Black Friday it's a consumer based model and a consumer website, and a particular module B is actually having a lots of demand. which means you need a server. You need many servers. Now, what are we? Because we have one particular smudged application, we actually need to have a server or many servers for whole application rather than for a particular application for particular feature of that whole smudged application, right? So which means scalability is also a problem as well, because when website traffic is going to be high, then you need to have multiple servers, because that server will be shared again across all application and not just for that particular feature. So that's not good, right? That's not ideal, that's not what we want. Now this particular issue is these days could be resolved with for example elastic servers, right? So using elastic servers, you could have, a pattern where you can have multiple servers, but but for that particular purpose, you need to have a separate application as well, isn't it? Because then you need to understand, you need to tackle that in a different way. Now, somebody actually thought, okay, hmm, there must be a better way. We might be thinking about, a particular thing and not and forgetting another thing. So then basically this concept came up that said, well, let's create application in a modularized way, but actually those modules will be integrating or interacting together using HTTP or REST API calls. Still, you have one web application, but actually within the web application, you have a particular mini apps that's actually integrating and interacting using REST API. And so in that way, what will happen in that case? For example, let's say there is a demand at a particular time frame on the payments app. What you will do, you will actually you don't need to worry about, because is loosely coupled. You need to have, multiple servers, but not for all the whole application, web application, but just for that particular payment app for that particular time frame. In that way, you are still intact with your REST API interaction with other mini applications in this whole web application. At the same time, you are giving a flexibility to the consumers, so that they are accessing more in that particular time frame. Now, what are the advantages? It means there are few advantages. Of course, clearly we can see there's advantage that now you have flexibility, that you can have, if you want, you can have multiple servers for a particular mini app within the web application. Now, it actually, de-risk the deployment, because then in that case, you don't need to think about dependency. You don't need to think about maybe a full regression testing, because it's part of that. And then scaling of that particular application is easy as well, because then it's not interdependency that, okay, one particular application is actually, needs to be deployed with that, because it's a it's a dependent code, right? So that's the background that we have. Now let's talk about what are we what is actually microservice, right? So in kind of definition point of view, microservice is like, is a mini applications. Those mini applications talk to each other, right? Talk to each other using REST API. And these mini applications have no dependency on each other. So when these mini applications will talk, they will talk on HTTP call. Now, of course, there are advantages here. First, it's a loosely coupled, right? And is people have kind of, arguments on that it's basically in between service oriented architecture and the web application, which might be the case as well, which means that you still use SOA. And uh, also one more thing, which is a big part of this thing, is actually complexity, hiding the complexity. So let's say here we are talking about service A, service B, service C. Let's say service A has so many complexity, and for example, if we want to have a real actual interaction between service B and C, then they need to actually follow that pattern as well of service A. But in that case, Because it's a REST API, it's a HTTP call, they don't need to worry about what's complexity behind the scene of the service A. That's a benefit. Now, deployment is, of course, you have a flexibility, and is not technology dependent, is independent of any technology, which means service B could be built on another language, service C same, and service A again the same behavior. It could be same, but it could be on different technologies, so you have that flexibility. And of course, it's easy to have scalability, for a particular time frame, for a particular service. Now, of course, as we mentioned, we have some disadvantages, right? So if you are talking about very few mini language, mini applications, which is, I think, is okay from an enterprise architecture point of view. But if you talk about many mini applications, then you might be going into kind of like in a difficult situation, because in that way you will need to have, let's say, if you have hundreds of mini applications, well, at some point you need to have a dependency on that, because otherwise it will be very difficult. And also the deployment is going to be complex, because if you have hundreds of mini applications, is difficult. It will make difficult for that particular application, might not be, but the overall scenario perspective, then definitely. Uh, and the question will raise in your mind that, okay, what is the pattern that we need to follow to say that, okay, well, by this time, this is a particular big application, and when we reach this particular level, then we will say, okay, well, you know what, we need to decompose this whole service to be a mini service. And that's where this concept comes up. And or maybe you need to talk about an idea of service discovery. You need to think about how we actually decompose and having a different service discoveries there. Okay, so that's the overall what is microservices, and the background where we have come from. Now, definitely, as I mentioned, one size doesn't fit all, which means that it doesn't mean that microservice is a solution for everything, or for every complex engagement that you have, or that you are dealing the issues in the complex architecture. You always need to think about, and you always consider the right architecture for that particular requirement at that particular time, because the requirement change, situation might change, and your solution and your requirement might require to rethink. So now let's talk about where Salesforce comes in. And do we have really like microservices within Salesforce, and how Salesforce define those, and why, and Salesforce says that, Salesforce, from Salesforce point of view, Microsoft falls in between somewhere SOA and the modern design patterns that you build for integrations. Right. So let's talk about Salesforce platform. So microservices is definitely a way to actually have application with discrete and decoupled code. Now, modern no, in the modern development, we are in a faster move development world, where we need to actually develop applications, and as quickly as we can. And so, which means that deployment should be quick, fast, and we should not be, and customer and client should not be worrying about, okay, what's the server, what's the cluster, what's the slices, what needs to be done on the infrastructure side. And from a Salesforce point of view, Salesforce is a multi-tenant platform, right? And it provides as platform as a service. It definitely handles robust and automatic API services, versioning, upgrades, maintenance, everything, right? Um, so Salesforce has view what Salesforce defines as microservices. So Salesforce has fundamentally three different approaches of microservices. Okay. Number one is data object microservices. Second is custom microservices. And then we have process driven microservices. Let's talk about into detail what are those. So data object microservices. So this is like a Salesforce, definition point of view. Is that, and that's how Salesforce represents, is that when you are interacting with any Salesforce object, now behind the scene is a service for you because you can easily create those objects. When we talk about a standard object, native object, we're talking about a standard custom object, we're talking about external data objects, and now even we're talking about big objects as well. um, and those objects, when you create those objects, what happens? Those objects straight away automatically are available in the API and exposed to API. You don't need to do anything else to make them exposed to API, right? So as soon as you create a apex, you create a object, is available to you. It's available to you in the API, and you can go and basically access through the API, which is another service. We also have custom microservices. Now, custom microservices are, we have multiple approaches in custom microservices. Number one is, for example, you have now Heroku, which is a platform as a service. You use that to build your own application on non-Salesforce language such as Node.js, Ruby, Java, any other language, Python even, and then basically you upload that and deploy that on the Heroku. Now, what will happen in that case? If that's a service as well, that's a service to you. You can build it. You have a flexibility because that gives you a flexibility and advantage, which means that you can build any service outside of Salesforce. The benefit is the data is in Heroku, and Heroku has a connector available that can pass the data easily to Salesforce. So that's the benefit. Then also you have, of course, Apex REST service, which we will talk about in detail later. And then also we have object-oriented, um, you know, the action-based microservices, right? Now let's talk. Let's go into the next, and then we'll go into the detail of custom microservices. Now we have process-driven microservices. Now those are the services where you actually so let's say if you create a object, or if you use that standard object, you can create, of course, custom fields in that standard object. Those fields are automatically available to your integration, to your API, and those can be accessed easily. And also in those objects, APIs can have correct permissions, right? So those correct permissions are actually accessing is a service, is a mini service. Create, update, delete, and read. So these are basically services to your service, to you. You can use it, and it's individually it's a service. If you want to just update, just use update. If you want to just delete. If you want to have upsert, then you use upsert. On the other hand, you also have within Salesforce platform, you also have what we call flows or lightning process builders, right? Where you have flexibility and options to create flows. And by the way, those flows and process builder are actually more efficient than what we actually go and create, any custom code, because those are out of the box platform features, and those platform features actually respect the platform considerations. Now, let's go into the detail of custom microservices, and let's talk about Apex REST services. So, custom microservices has an option. Number one option is you can use any language, you can build that program, you can deploy that program on the Heroku, and Heroku can actually interact through that program to any external, even your website as well, right? So you can do that. And using Heroku connector, we can pass that data easily to Salesforce. So you have a benefit, and you use that custom microservice in that manner as well. Now let's talk about what are the other features that are available within the custom microservices on Salesforce platform. Number one is, for example, you can easily create quick actions, right? And in those quick action, you can have any function. For example, log a call, create an opportunity, update a case record. Many other features are available. Create an event, task, activities. So you can have that option. Now, why do we use and when do we use this option? Whenever we thought we whenever we think about, we want to utilize the standard features of declarative features of Salesforce. That's where, because you don't need to write a code. It's exactly same action-based microservice, and you just use that because it's available on the Salesforce platform. Now let's talk about Apex REST, right? Or in simple words, how could we expose Salesforce with our own logic as a microservice to external, externally available microservice? So there's a pattern there, of course. In Salesforce, we have many annotations like @future, @read only, many other annotations. We have one specific annotation for Apex REST, and that is @REST resource. It has a specific URL, which you create your own URL, and it has some functions, right? HTTP get, post, put, patch, delete, right? Get, use it when you want to just read the data from Salesforce, right? Post, use it when you want to insert something. Put, you use it when you want to have a kind of a absurd kind of function. Patch, you want to update something, and delete, you want to delete any resource in Salesforce. And you can have a Apex class, and within the Apex class, you can have all of them, you can have any one of them, but every class should have only one each particular this function. You can't have multiple get in a particular Apex, or same goes for other functions as well. Always one Apex class have one function, because that's how the structure and pattern, that's how the sales will recognize as this particular resource is being called, and what parameter is coming up, and based on that it actually recognize the what call needs to be made, either get, post, put, patch, or delete. Now, one of the biggest advantage of having this particular Apex REST microservice and exposed as a microservice is that it actually hides the complexity of Salesforce. Because if you have ever used Salesforce standard REST API, you have a specific pattern that you need to follow here, and that has many other things coming up. And if the external system doesn't want to have that complexity, and you have very specific function to do, then you could utilize Apex REST to actually do that, because in that way you have your just specific logic, and that's it. And when external system will call that service, it will get exactly that function. Of course, there's no dependency on the REST interface on internal Salesforce, and also basically there's no dependency. For example, updating one service doesn't require changing others, right? And independent of any technology stack as well, because external system doesn't need to worry about what language we have written this code. They have just HTTP call. They need to pass this into this particular REST resource, and that's it. And of course, at the same time, the response back will go to the external system. Now let's talk about how do we do that actually. How do we call that? So if you want to do a get call, so first of all, this is the code. So of course, as REST resource, you are mapping. You provide a particular namespace, and you provide versioning as well. I will go into the versioning later. Why versioning is also very important. Of course, the class should be declared as global. It's public access modifier global. Of course, HTTP GET we are doing here. It has its own methods called REST context of REST request and REST response. In that you get the actual response. And here what we are doing, we are actually expecting in the particular URL resource a customer number. When customer comes in, we are reading that customer number. We are querying a particular account record in Salesforce, and we are actually returning that account record to external system. That's it. And if you do that, this is what you get. So you get attributes like account, it's a particular resource URL with the ID, of course. And of course, it has other parameters, whatever parameters we have given into the SOQL query. So ID, name, customer number, and a website, right? So in the URL, if you see up here, you have a get. You have, of course, your domain name, which is sales, which is in this case your If you haven't really enabled custom domain, is your instance name. Otherwise, it will be your my domain .my.salesforce.com / the, that will be changed, and that will be consistent because that's the service that you are going to use across all your Salesforce environments. So you have Apex REST. Otherwise, in the standard REST API, you have data here, right? You have service name, of course, you have version, and you have customer number. As you pass that, you actually get the response back. And we can have whatever response back we can have, right? Because is in our control. Now let's talk about how do we call other functions. If you want to do post, then you do something like this. But for post and put and patch, you need to have a HTTP request as well. So external system needs to pass the HTTP request. So request body will be something like, if you are passing in JSON, you will be something like this. You know, and by the way, if you have a benefit as well. You can pass in JSON, and also you can pass in XML as well, right? It works in both ways. You can pass request body in XML as well. In XML, you have a different pattern, definitely. You have a different format, but you can do that. And same goes for passing response back from Salesforce as well to the external system. You can yeah they can get it in response format, like application forward slash in the JSON, or application forward like XML format, whatever you can get it. You can get in either way. And of course, if you want to delete it, you can pass the customer number. This is another thing, and just highlighting the version, why versioning is really important. Because let's say if you don't include version and you deploy this code to the production, it's good. First time you deploy it, great. But let's say the service that is the external service that is using this service to call their service Salesforce is having issues in production, in their production actually. And then you wanted to actually say that, you know what, let's let's change this service. And because they are having issues, they want us to change something in this service. But the problem is, when we say problem, their existing integration is basically is integration of problem of request body or response or something. It's actually working, but they want to change something. If you have a version, what will happen is that you first deployed in the version 1, you keep going into production. In production, they are using it. At the same time, you have another version with the same code, like of course updated code with the same class name as it is the same service, and you can have version 2. And by the way, let me be specific. Class name can be anything. The main thing is service. Class name can be anything. The service is really important. The service is this in the URL. So you can, when you deploy into the version 2, you can give another name, maybe class name 2. And then when you deploy that same service, but now let's put version 2. In that case, what will happen in the production live environment? You are not interfering. You're not straight away deploying. And then, because if you deploy straight away with the version 1, it will overwrite. And then external system is not expecting that response. So you will have a problem there in production. In order to avoid that, you can have two versions together in parallel working. And then once they are happy with version 2 testing in production, they are happy with that, we can live with version 2. We can delete, or we can go back and roll back the version 1, or whatever way you do the release management, right? So that's the benefit of having the version. Right. So there are considerations as well in Apex REST that um, you should be careful and consider when you implement. Number one thing definitely is in Apex, which means we're talking about considering Salesforce governance limits. We are also talking about large data volume, because if there is a large data volume, that means there is a problem in processing. If you have large data volume, and that, in a particular object, let's say, I don't know, let's say account, and you are doing something in account in this particular service, then you might need to query all, or something like that. Then there's a consideration of large data volume as well. Performance, again, you need to handle error handling gracefully. That's really important, because the other external system is relying on you. So you need to make sure that you are, because you are handling that properly. Naming convention, make it consistent, right? What I'm talking about the service name. Make it consistent. If you have multiple services, let's say if you want to create another service of contact, make sure that you have a consistent name so that external system party and team members, they don't actually get confused. Put a version number as we discussed earlier in the RESTful. It gives you flexibility, and use a consistent request and response body so that in that case, again, they know what's coming. And avoid having back and forth communication. You can, I'm not saying that you can't, you can, for example, if they access this service, and if you do something in the DML and they want the response back in through that DML, you can do that. But avoid having that because it's a REST service, right? So of course you are consuming API calls, that's fine, but at the same time there's a processing there as well, right, within Salesforce. In limited capacity and the functionality, that's fine, you can do that. But if you have you know heavy lifting processing there, and you are relying on the Salesforce side, it's better to have a response back in a quick manner, and then later on they can come back and get the response back from Salesforce. Right. So Salesforce provides some good microservices designs which you should consider before you implement. Now, Apex REST is definitely uh, a, a platform feature which you don't need to worry about too much. But if you're relying on other microservices that Salesforce needs to call or MuleSoft needs to call, that you should consider these patterns, right? And in regardless in even in Salesforce Apex REST as well, you need to consider that as well. Because for example, Apex REST is HTTP call, which means it can be called by anyone from anywhere. It doesn't require you know doesn't require middleware. So first of all is that the decoupled service, right? And make sure that it eliminates the complexity, right? And that's why we are saying a microservice. It's mini apps. um, Also, it should only fulfill a single function. It doesn't do many other things. For example, let's say if you want to do in a composite way, let's say create a person account, create contact, create another custom object record, and create do, and then basically comes back with the response. It's difficult, right? It's not then mini application. It's not that microservice either. So you need to consider that part as well, which is really important. Also, as I mentioned, make sure that it's, well, of course middleware can call, no problem, but just don't rely on that okay, well, because you know it requires that and that's why we are doing it, right? It should not require the introduction of the new middleware. Okay, that's really important as well. um, and also, the accessing the data should be consistent. So it should access Salesforce in a consistent manner, right? So for example, if the service is for only for account, make sure it's only doing account work, right? If it's only for invoices or orders, make sure it only does that particular function. So that's and accessing the data back and forth, request and response, make sure it is very consistent. You could have many application in that way if you don't follow that. So that's really important. Okay, and with that, yeah, these are the different resources that you can go and access that. Um, I would highly recommend this, uh, you know, test in your developer org, Apex Press if you haven't really tried it yet. It's really simple. You can test it through Salesforce Workbench if you are if you are struggling with any other thing. There are tools which you can test that as well. Yeah, both formats, in JSON and as well as in XML. Okay, great. With that, we can take questions. Yes, absolutely. I think there's a question they want is increase API calls when we have multiple mini services. Yes, absolutely. Well, API calls will even consider will come in consideration definitely in the later stage. But first is again, why are we doing this particular thing, and why are we going to use REST service, right? Apex REST service. That should be the first question. Do we really need to do, right? For example, let's take an example of let's say that there's a there's a order in the order record in external system, sorry, in Salesforce we are maintaining that, and we want to have update back into the service. They can come back, they can call this service and basically get the relevant line items, because that's important for them, because then they need to they need to produce invoices, right? This is just an example there. And that has been, I have seen that has been implemented in some of the pharmaceutical areas. So that's just an example. So definitely, of course, you're right, API consumption, we need to consider that definitely. But also we need to consider that, why do we do that? Do we really need to do Apex REST service, or can we do something else, or can we hand over this stuff to middleware if we are really using middleware? But that's a very specific part that Apex REST does it. It's a single dedicated function, consistent response, and consistent request, and make sure that you have a consistent pattern to follow. Any other question? All right, great. um, I don't know who is moderator, Rida.
Yep. Okay. So yeah, the thanks Abrar for the session.